Hello, welcome back to GradMates. I'm Peter,
I'm Caitlin.
and today we have a problem submission.
I know.
I'm so excited.
I know someone actually submitted a problem.
Honestly, this looks kind of like a homework problem I would assign.
It kind of does look like it came from my math lab. The way that.
Yep.
This could be one of our students. Maybe. I don't know.
Who knows?
Well, I'm surprised we actually got a submission this early on in our journey, but
This is a monumental moment in our career.
I know, a submission.
Our internet career.
So yeah, submit your problems. Be like this person. They did not want to leave their name, but we are going to give them a shout out anyway. Shout out to whoever sent this.
Right, shout out to you. So I was thinking maybe I would solve it first, and then you can solve it.
All right, let's do it.
All right, so let's do this. So here we are looking at a half-life problem, and whenever you're talking about half-life problems, you are going to be working with exponential functions. Now, I'm going to show you how I was taught. So I'm going to write A is the amount that I have left of whatever material I'm looking at, whatever this, so here it's radium, and then A sub 0 is going to be the initial amount. So my exponential function takes the form A equals A sub 0 e to the kt. Now, if k is positive, it's growth because the base e is greater than 1, and if it's negative, you know it's decay. So you can use the same model every time and just say, oh, well, k is negative, so I know it's a decay model.
Okay.
So it tells us the half-life is 1,690 years, so that's going to be my t. And then it tells us that 40 grams are present now.
Switch 9 and 6.
I might also be a little dyslexic.
I realized I might be too.
Oops. All right, so we have 1,690 years for our half-life. Now it tells us there are 40 grams present now. So at time 0, that's going to tell me I have A equals A sub 0 e to the k times 0, which is just A sub 0, times e to the 0, and then e to the 0 is 1, so I just get the A sub 0. So this is just to remind myself that the A sub 0 is just my starting amount. So the A sub 0 is the 40. Now I wouldn't actually plug that in. That was just for you guys to see that are watching, but that's my initial amount. And I want to figure out how much is left after 130 years. So what is A when t equals 130? Okay, so we're going to start out with saying we have 40 grams present now. And then if we're talking about half-life, it tells me it takes 1,690 years to become half of how much I started with. So that's going to put me at 20. And then I have e to the k. Well, the time it takes to get to 20 grams left over is that 1,690. So I'm going to divide both sides by 40, which is going to give me a half on this side. And then I have e to the 1690k. And then I'm just going to convert this to logarithmic form. So it's going to be a log base e, which is a natural log. Natural log of 1/2 is equal to the 1690k. And then I'm going to divide both sides by the 1690. So natural log of 1/2 divided by the 1690. Now I know this is a negative value because when you do natural log of a number between 0 and 1, it's going to be negative. So since k is negative, we're decaying, which makes sense because it's a half-life problem. So this is my k value, and it's approximately negative 0.0004. I guess I'll just use that. You just stop there.
Yeah.
Do you think I should use more decimals?
No, I think that's okay.
Okay. All right. So now that I know my k value, I can rewrite my equation. Well, not 80, 40. I don't know why I'm thinking double. And then the K value is the 0.0030 times T. So now that I have my exponential equation, I can plug in different values of T to tell me how much of the material is left over. So when I plug in the 130, I'll have 40 times E raised to the negative 0.0004 multiplied with 130. And give me a sec for that. Looks like 37.97 grams. Now, I like to pause and just kind of say, well, if the half-life is 1,690 years, if I'm only looking at 130, I should have more than the 20 grams, which I do have more than the 20 grams. So that is how I would go about solving these kinds of problems.
Wow. Okay, very different than how I do it. So,
I have my gut's telling me you're about to put me to shame.
so what do we know?
We know
let's
the
see, we
initial
know
amount was
half-life is 1690.
Yep.
Our initial amount is 40, and we know the time is 130 years, and we want to know what's the final amount. Okay, so the formula I use is we have some amount. When we have some initial amount, we're dealing with half-life, so the base of our exponent should be half, because each time we're keeping half.
Okay.
And then instead of being raised just to the t, it's t over whatever the half-life is. So our 1690. Because this fraction here, if I had, well, we have 130. 130 out of the 1690 tells us what part, like how much of that half-life time span we have. So we're taking half to that amount.
Okay.
So I can just plug in what I have. So I know my initial amount was 40. 1/2, I know I'm doing
This is
130
stupid.
years. And then I can just plug that into a calculator. So let's see, we got 1/2 raised to the 130 over 1690. And then we're going to multiply that by 40. And we get 37.
Well, look at that.
0.92.
I don't like
which
you right
is
now.
about, it's not 100% close to what he had, because we rounded the decimal.
Right. We had
here.
some rounding in the way I did it, so that's why our answers vary a little differently.
Right.
Yeah.
And yeah. Isn't that cool?
Look how much less work that was.
Crazy how two different formulas get us the same answer. Crazy.
You know, and that's crazy because that formula makes so much sense, because if you plug in t equals 1,690, that's an exponent of 1, and then 1/2 to the first power is just 1/2, and so 1/2 times your initial amount would be half of what you started with. So you don't even, well, I don't like you right now.
Works for double time too. You could use
Your way is better.
Is a sub 0
And I bet you would use a base of 2 if you're
Right.
doubling, right?
over t over d, where d is the double time.
And then
Cool.
you would use a base of 3 if you were tripling, and then D is the
Yeah.
tripling time. That's so
Exactly.
crazy. Why was I never taught this?
Because you didn't have me as a teacher.
Oh my gosh.
Alrighty, well, that was fun to do a problem submission.
It
So,
was.
Submit a problem.
Please send us problems. We are still bored. We weren't bored today because we actually had a problem submission.
Right.
So we're going to get bored very soon. So send us your problems.
And if you're the one who sent us this problem and you're watching this, we're going to send you this video so that you can watch us go through your problem.
Wow.
Alrighty.
Good times today.
I know. We'll see you next time.
See you next time.